Hi, so this is the next hands-on video in preparation for considering if building C was smart. In the previous video we accessed the curve geometry for each of the spaces, and in this video we're going to continue working with the same file, and we're going to look at creating simple line curve visualization that is going to allow us to plot each of the different sensor values on a simple line curve. So I'm going to go back over to the previous file that we created for reading the data, and the first thing I'm going to do is just change some of these names so they're a bit more obvious. I'm going to change A to spaces. These are going to be our curves. Going to add another output parameter, so we've got to zoom in until we can see these add and subtract, and we're going to put another one in there which is space data. And the other thing that we can do with these components is right click and give a more meaningful name. So I've got my shape check there, and I'm going to keep saving the file as I go along. So once we've changed and added these new output parameters, we can double click on the component, bring up the script editor, and previously we had an output component that was just called A. This is now spaces, so we need to change the name of that. And we're also going to use space data as an array, and we're going to access just the sensor data and append it to that array from the object, JSON object, and this is called sensor records. So in our object here, we can double check the name, and then this is going to produce, or this is going to allow us to access an array of sensor record objects. And we should just test that. If it works, click OK, check here, and this should say that we've got IronPython runtime lists coming out of there, and that's what we're going to work with. So what we need now is a second Python component where we're going to start to process this data. And what we're going to do is we just want to access a single space. So first of all, this we're going to call data. This is now a list of lists. We're going to make sure that Grasshopper Python knows this is a list. Connect our data. We're going to change the name of this input parameter to ID, and then in order to define an ID, which is just a simple number, I'm just going to double click, type 15, and that will generate a Grasshopper number slider. And the other input that we need there, so we can zoom in, add a new input, and this is going to be the name or the attribute that we're looking to access and plot as a graph. And this is a single value, and I need to define this as a string. And the way we're going to define this is using a Grasshopper tool from the parameters and the input menu, and it's called a value list. And I'm going to copy and paste the values that we need in, and you will need to write them into your value list. So to edit the values, we right click, left click on edit, and these are the contents, or the constants, sorry, of our list. So these refer to the description of each of the sensor values in our file, and these names here are what appear on the component on the outside. So if you pause your video, add these values, and then come back, I'm going So now we can see we can choose one of those, and then the result is connected to the attribute here. Let's start off with temperature, and then we just need to set up our code in order to extract temperature data from the space with ID 15. Before we do that, we should just set up our output parameters. We're going to have 3 output parameters. The first is called x values, y values for our graph, and then we're also going to create time, which we'll use for labeling the graph. So if we go into the script editor, again I'm going to delete this boilerplate, and we're going to say that all our outputs are arrays, and we want to access just one of the values here, and so we're going to access each record, so each sensor record, each time-based record in the data of ID 1. So this is accessing just one of those sets of data. And then our Y values, we will append the record with this attribute, which currently is set to temperature. And we're also going to create, in order to plot these with an x-axis, we are going to append a single value x, which will set initially as 0, and then every time we pass through one of the records, we'll increment by 1 in Python. So increment, we do x plus equals 1, and then last of all time, append record, and here we have to remember that we are accessing a record with the name dt, and we can test it. Oh, we have an error. Index value got float. This is because the ID here should be defined as an integer data type. Now we seem to be okay. Click on OK. Just check that here's a load of time, date times coming out, Y values, X values. And here, this is where Grasshopper can be quite useful. With a double click, type in PT, and the component I want is construct point. I'm going to connect the X and the Y values, and we can see this little scatter there. And then from these, I can quickly generate a polyline, make it a bit cleaner, right click, select preview to hide those points so we just see the polyline. And then in order to label the X axis, I'm going to copy and paste this point, right click on the Y, disconnect the Y input, so these are now just points along the X axis. And then for each of these points, I'm going to create from the vector menu a plane, construct plane, so a plane with this origin, and I need to do a little rotation so the x-axis points up, so we're going to use the unit y to point upwards and the unit x to define the y-axis. And we want to flip this over, so I'm going to multiply this by -1. So I right click on the F, set number -1, and that plane basically gives us an input location that we can use to create a text tag. That's the location. This is the text. Looks pretty good, just need to change the size. The size is currently 1, so maybe if we half that, double click, type in the value, we'll get a slider. Here's our little graph. And now, if I quickly change this morning value to, say we go for a week, takes a second or two to load. And then once we've loaded up, we can then see that simple line graph across the course of a week, where each day we have kind of peaks during kind of 9 to 6 or maybe a bit later, and then nighttime lows.